right? And if you have any questions, okay, so please still type in the chat window, okay? So I have office hour from 3 to 5 today, okay? So if you have long questions, okay, so also kind of the homework, whatever questions, okay, you can also come to my office hour, okay? Right. And if you write here on the paper, that's fine, okay? So that's actually kind of a pretty good one, okay? Okay, so last time we talked about kind of the use the widespread theory, try to predict the molecular shapes, okay? So here's a very good chart, okay? So we showed all the kind of different molecular shapes, okay? And all their kind of bond number, lone pair electrons, okay? And then based on that, okay, so you can predict kind of how many what's the bond angles, okay, and also the what's molecular shapes, okay. So and even okay give you some kind of examples, okay. And so this chart already upload onto EduCat, okay, so you can download it, okay, study it, okay. And so again for our organic chemistry 1, okay, so we only worry about kind of electron density regions up to 4, okay, so 4 here, okay, so those I will maybe test in the exam quiz, okay. Above 4, okay, so just get a little bit idea, okay, so far don't need to worry about it too much, okay. All right, okay, so continue our lecture, okay, so we have a little bit left over for chapter 1, okay. So we already know how to predict kind of molecular shapes, okay, by the widespread theory, okay, and combine with the bond polarity, okay. So in probably last week lecture we learned kind of how to predict kind of polar covalent bond, okay, or non-polar covalent bond or ionic bond, okay. So combine these two information, molecular shapes, okay, and also bond polarity, we can predict the polarity of the whole molecule, okay. Keep in mind this the polarity for the whole molecule, okay. And so for one molecule is polar, as we fulfill the following two conditions, okay. First, this molecule has kind of the polar bonds, okay. So if there's no polar bond, okay, for example, the methane, okay. Right, methane has only CH bond, okay. CH bond is a non-polar covalent bond, okay. So if there's no polar the covalent bond, okay. So that's just the whole molecule kind of not the polar, okay. But if there's the polar bond in the molecule, okay, so you have to follow also the second kind of conditions, okay. A polar dipole moment of all polar bond cannot cancel out each other, okay, cannot cancel out each other, okay. And so that means the whole molecule should have kind of net dipole moment, okay. So the vector addition is not there, okay. All right, what's that mean, okay? And someone write pretty long one, okay. Yeah, that's right. Okay, so about lab report, okay, so we can discuss kind of later after the class, okay, and also I have some office hour after the class, okay. Okay, so following kind of two very good example, okay. And the first one is the carbon dioxide. Okay, carbon dioxide is the linear molecule 180 degrees. Okay, but in this molecule there are kind of the polar bond. Okay, CO bond. Okay, but these two polar bonds point away from each other. Okay, so and cancel out. Okay, so 180 degrees. Okay. So in this case, for all molecule, okay, whole molecule is the non-polar. And another example is water. Okay. Water has kind of this bent structure, okay, we learned in the previous lecture, okay, so they are 105 where the degree bond angle. And so there are kind of two OH bond, okay, so both are polar, okay, and these two polar bond cannot cancel out each other, okay, because they have some certain angles, okay. So in this case, for water molecule, there's the net dipole moment, okay, so point up like this way, okay. So that's you have to little bit keep in mind, okay. So sometimes two molecules have similar formula, okay. So but they may have different kind of molecule shapes and then eventually different kind of the polarity, okay. Yeah, so I will post the homework, okay, after today's lecture, okay, so yeah, about chapter 1, okay, both online homework and also actual credit homework, okay, so yeah, just waiting for my email, okay. All right, so now, yeah, it's you guys' turn, okay. Try to work on the following 2 pairs of molecule, okay. So yeah, the first pair is CHCl3. Second is and also the CCl4. Okay, second pair are PCl5 and also ICl5. Okay, and try to draw their the Lewis structure. Okay, and then predict their kind of molecular geometry, okay, molecular shapes. Okay, so tetrahedral or kind of the planar, okay, or some kind of square by pyramidal, whatever. Okay, and then in the end, okay, predict these molecules kind of polar or non-polar. Okay. All right, take a try. Okay. All right. So this time, yeah, we'll try something new. Okay. So yeah, let me see. Okay. Menu. Okay. So there's the one menu called kind of annotate. Okay. So when you click it on, okay, a lot of tool come up. Okay. And it's anyone want to be volunteer, okay, to draw CHCl3, okay, and also CCl4, okay, on screen, okay. So yeah, share with the whole class, okay, something like this, okay. All right, something like. Okay, let me clear it. All right, anyone want to take a try? Okay. Yeah, draw the first pair, okay. So yeah, the molecule, okay, Lewis structure, okay, CHCl3, CCl4. So these pair are quite easy one. Yeah, that's through Zoom, okay. So yeah, I don't know for you guys, okay. For me, it's kind of at the bottom, okay. So that's just by the share the screen and then show the pores, okay, whatever, okay. So for you guys, yeah, maybe somewhere, okay. Yeah, on the top, yeah. On the top, yeah. For you guys on the top, okay. So yeah, just click on it, okay, and then you can draw whatever you want on the screen, okay. All right, someone draw some kind of line, okay. So take a try, okay. Try to draw these two molecular kind of Lewis structure, okay. So someone want to take a try, okay. All right, anyone want to be volunteer? Take a try, okay. Okay, good. Okay, I see that's a H. Okay, looks like CR. Okay. All right. Okay. So last year no done yet. Okay, no done yet. Okay. Okay. Yeah. Other person can also try it. Okay. No done yet. Okay. So yeah. Remember for Lewis structure, okay, so you also need the label lone pair electrons, okay. So I add lone pair electrons for you. Dot. Yeah, that's correct. Okay, pretty good. Okay. So someone showed me also the CCl4. Okay, so yeah, the purple one. Okay, pretty good. Also labeled the lone pair electrons. Okay. All right. Okay. So yeah, and also yeah, you guys just give some of the right answer. Okay. So yeah, the CCl3H is polar, and then CCl4 is non-polar. Okay. So yeah. To see that, okay, so I'm sorry, okay, I have to clean up here. You guys, that's pretty good, kind of, you guys did pretty very good. I have to clean up your clean, okay, so, all right, so for the to determine kind of the polarity of molecule, okay, so yeah, you have to try to draw the molecule kind of in a three-dimensional way, okay? I just ignore kind of lone pair electrons, okay? Right, so for the CH bond, it's kind of non-polar, okay? Don't worry about, okay? So, but for the CCr bond, okay? Right, so yeah, the bond, the dipole moment should like this, okay? So yeah, they cannot cancel out each other, okay? There's kind of pure dipole moment for the whole molecule, okay? So that should point down, okay? Something like this, okay? So that's here going down, okay? And but yeah, for the CCr4, okay? So yeah, just ignore the kind of lone pairs, okay? And although there are kind of dipole moment for individual the bond, okay, but they just kind of all cancel out each other, okay. So there's no dipole moment, okay. So for CCr4, it's kind of non-polar molecule, and then for CHCr3, it's kind of a polar molecule. That's pretty good, okay. All right, okay. So now we try a little bit harder one, okay. PCl5 and also ICl5, okay. Can anyone try to use the anode case so show the structure of these two molecule, the Lewis structure? Okay, I see. That's probably the P phosphorus. Okay, looks like Cl. Okay. All right. Someone also try the ICl5. Okay, good. Yeah, that's right. Okay. Remember, add the lone pair electrons. Yeah, for these two, you better use the method 1, okay, to draw their Lewis structures. All right, good. Okay, lone pair electrons. Yeah, lone pair electrons. All right, once you done drawing the Lewis structures, okay, so please type in the chart window, okay. So what's the molecule shapes of these two molecules, okay, and then is polar molecule or non-polar molecule? All right. Knows exactly, okay. So far, no one gave me kind of a totally right answer. That's right, okay. Someone told kind of right one should be polar, okay. So far, the yellow one is wrong, okay. So the yellow, the ICl5, okay. Okay. So the right answer is the PCl5, okay. So it's non-polar, okay, and ICl5 is polar, okay. And the left red molecule is kind of a right structure, but here the left one is right molecule structure, but here the right one case, so the yellow one is wrong, okay. That's right, okay. Forgot lone pairs, okay. Okay. All right, last thing kind of can anyone tell me what's the molecule shapes of these two molecules, okay? What's molecule shapes for the PCl5 and also what's molecule shape for the ICl5? That's right, okay. No tetrahedral. Tetrahedral normally only for the 4 electron density regions, okay. So the OCR5, okay. which one is the yeah trigonal bipyramidal? You have to tell me. Okay. All right. Okay. So I guess yeah now because these two are pretty hard. Okay. So now I have to kind of go through these two. Okay. All right. Okay. So yeah. For the two students draw these two structures. Thank you. Okay. So I have to clean it up. Okay. So yeah. All right. Okay, so yeah, like I said, kind of yeah, for these two, okay, better ways kind of use the first loose method, okay. So yeah, you need to count the total valence electrons, okay. So yeah, phosphorus 5, chloride kind of 7. We have 5 chloride, okay. So should be kind of 35, okay. So that's give you the totally the 40 valence electrons, okay. Right, you put the phosphorus in the middle, okay, and then try to draw the bond, okay, connect with all the chloride, okay. Right. And that's should use up kind of the 10 electrons, okay, because we have the 5 bonds, okay, each bond got 2 electrons, okay, so that's 30 left, okay. You need to put these 30 electrons on outside the kind of the chloride, okay. So yeah, that's actually the one student already showed the right structure, okay. So yeah, 5 chloride, okay, will use up all the 30 electrons, okay, because each chloride will take 6 electrons, okay. All right, and once you're done, okay, so the better we draw is kind of a more 3-dimensional structure with the using Weisberg theory, okay. So yeah, I just ignore the lone pair electrons, okay. All right, okay, so that's this 3-dimensional structure, okay. And then these 3 chlorides in the same plane, okay, and then these 2 chlorides, one above it, one below it, okay. So that's some student already typed the right answer, okay. So this one should be kind of a trigonal, bipyramid, okay. All right. And because all these 5 kind of PCR bond kind of cancel out each other, okay. So yeah, they have kind of type 1, but totally symmetric, okay. So the whole molecule is kind of a non-polar. Okay, so now we move to the ICL5, okay. Iodine 7 electrons, KP minus group 7, okay. And chloride, okay, so 5 chloride still give kind of 35 the electrons, okay. And then total valence electrons now is kind of 42, okay. All right, so we do the same thing. Iodine, so least electronegative atom put in the middle, okay, and then connect with the chloride, okay. Cl, okay. So use up kind of 10 electrons, 32 electron left, okay. And then we go ahead add the lone pair electrons, okay. So here. Okay, so now we use up kind of the 30 electrons, okay. Each chloride the 6, 5 chloride, okay, 30, okay. 2 electron left, okay. So these 2 electron you need to put into a center the iodine, okay. So that's here. Okay, so you cannot put down chloride, okay. So break up octet, okay. All right, and then in this case, for the real the structure, okay, something should like this, okay. Again, I ignore the lone pair electrons, okay. Yeah, this lone pair electron have to label it, okay. Ignore the lone pair electron on the chloride, okay. All right, so this the lone pair electron will take a 1 electron density regions, okay. And then this 4 chloride will take 1 plane, and then another chloride, okay, will above this plane, okay. Right, and so that's okay. So for the molecule shapes, okay, should be kind of square pyramid, okay. So someone answer give the right answer, okay. Okay, but little bit of shift here. But if I ask you kind of here the what's the electron density region shapes, okay? So that should be kind of here octahedral, okay? Octahedral, okay? Right. And now come kind of other people also ask kind of here the looks like phosphorus and also iodine kind of not follow octets, okay? So that's we talked about in the previous lecture, okay? So from the third period above, okay? So the atom has a d orbital, even kind of f orbital, okay? Can hold the more electrons, okay? So that's one follow octet, okay? So this phosphorus, okay? So now you can see kind of surrounded by 10 electrons, okay? And this iodine even kind of 12, okay? Iodine kind of because of the huge atom, okay? Yeah, you can hold as many as possible, okay? So electrons, okay? So those here little bit keep in mind, okay? Square pyramid, okay? So yeah. Go back here. Right. So yeah. 5 bonds with one kind of lone pair electrons, okay? That should be kind of square pyramid, okay? So that's here the little bit keep in mind, okay? Square pyramid, okay? So although I maybe no test in kind of the quiz exam, okay? So but you better keep a little bit the in idea, okay? Yeah. Right. So the last example actually kind of pretty good, okay? Showed you even these two molecules those have similar kind of formula, okay? So PCCl5, okay? So and also ICl5, okay? So but they may have different the molecule shapes, okay, and then different polarity, okay? So so the last one, okay? So this one should be polar, okay? Okay, because the four ICl bond, okay, so on the same plane can cancel out each other, okay, because they are kind of the 180 degree, okay. But no one cancel out kind of the ICl kind of above this plane, okay. So this one, okay. So for this molecule, actually there's kind of dipole moment, okay, not dipole moment like this, okay. Yeah. So so that's the probably we'll see similar question in the coming quiz 1, okay? So make sure you do it stepwise, okay? First get right Lewis structures, okay? And then use vice versa, okay? Predict kind of its molecule shapes, okay? And then in the okay, predict what's molecular polarity, okay? What's the dipole moment and direction, okay? So we'll do a little bit practice in the discussion tomorrow, okay? All right, so now we're done the chapter 1, okay? So I will give out kind of homework assignment, okay, both online one and also the actual credit homework, okay. So probably in 1 hour after this lecture, okay. Right. Any question about the chapter 1? Okay. Any question about the chapter 1? All right. Online homework is due like 1 week later, okay. So next Wednesday, okay, for chapter 1 online homework. And actual credit homework is due on the first exam, okay, probably like 2 or 3 weeks later, okay. Oh, that's a lot of questions. Yeah, online homework will be on smart work, okay. Yeah, that's right, okay. So dipole moment can move to the more direct kind of more electronegative atoms, okay. So they have kind of more negative charge, okay. So for actual credit homework, okay, so I will open some kind of the Dropbox on EduCat, okay. You just take a picture and then submit there, okay. So similar like you did for the pre-lab, okay. 3 hours, okay. So for the on quiz 1, okay. So probably I'll open from 8 to 11 in the evening, okay. So for the both this section and also the morning section, okay. So I will send out the email probably on Friday, okay. So give more detailed information about the quiz, okay. All right. Any other questions? Okay. So how to cancel out kind of the dipole moment, okay. So we'll do some kind of practice kind of in the discussion tomorrow. Okay, so I will show some kind of the better way to view it. Okay, and then show it. Okay, so if you cannot come to discussion, okay, so I will upload the discussion worksheet online. Okay, so try to practice by yourself. And so then you come to my office hours. Okay, I can go through the question with you. Okay. Acrocratic homework from the question are from our textbook. Okay, after chapter questions. Okay, after chapter question. All right, okay, so if there's no further questions, okay, we move to chapter 2, okay? All right. Okay, chapter 2 is called what's called, okay? Organic compound, first look, okay, so this chapter has several block of information, okay, knowledge, okay, so lots relate to each other, okay, so just kind of a little bit too diverse, okay, yeah. All right. So the acrocratic homework will be I will give kind of question numbers. Okay, you'll find it on the your lab the textbook. Okay. Right. So for chapter the 2. Okay. So first block about kind of the bonding. Okay. So actually, personally think they should belong to the chapter 1. Okay, but they put it into chapter 2 is fine. Okay. So we'll study kind of the bond strengths and also the bond lengths, okay. Right. And then second kind of we'll learn some other way to draw the organic molecule, okay. So far the way we learn to draw organic molecule is just loose structure, okay. That's the two hassle, okay. Too time consuming. We will learn some kind of much easier way, okay. And then once we learn some kind of either way to draw the formula, okay, so we can study kind of constitutional isomer, okay. So constitutional isomer are two molecules, okay, have same formula, but they have different connectivity, okay. So that's some hard part for this chapter. And then during this part, we will also learn how to calculate kind of the DU number, okay. So that's degree on saturation, okay, degree on saturation. So that tells you how many double bond, how many triple bond, how many rings in one molecule. And then the second block of your knowledge is about intermolecular force.
Hey, what's written in parentheses there? Strength and length?
Which one?
In parentheses, strength and length.
This one, constitutional isomer, and social short here.
Above there, strength and length. All right, I got it.
Oh, strength
okay,
and length. Strength and length. I'm sorry, okay. LENGTH, okay, so my handwriting is not so well, okay. All right. A bond, we will learn bond strength and also bond length, and then this is the bonding, okay. Bonding, okay. Yeah. Bonding. All right, intermolecular force, okay, so that's actually last relate to the first knowledge, okay, but we learned here, okay. And then based on intermolecular force, we can learn kind of the physical property of the molecule, okay. So for example, here the melting point, boiling point, okay, something like this. Those are determined by intermolecular force, okay, like the ionic bond normally have ionic kind of interactions, okay, has the higher intermolecular force, okay, so higher melting point, higher boiling point, whatever, okay. And then last block is about kind of functional group, okay. Functional group. The functional group is the one we try to classify organic compound, okay. So organic compound, there's maybe millions of organic compounds, and we invent a very useful, very efficient way to classify this organic compound. Okay, so it's alcohol, it's ketone, whatever, and then those the classification help you kind of study their chemical properties. So these three block knowledge is kind of has a last relationship to each other, okay, but our textbook put it in this way, we will study these three in this chapter, okay. The most difficult part for this chapter is the constitution isomer. I will show you guys kind of a way to draw the constitution isomer if we give you one formulas, okay, so that's the hard part, okay. All right, okay, so yeah, in chapter 1, we learned for different atom, okay, at the neutral condition, okay, so formal charge is 0, okay, they have kind of specific bond number, and carbon has 4 bonds, and nitrogen has the 3 bonds, and oxygen 2 bonds, and hydrogen 1 bonds, okay, so that's showed here, okay. And but for the atom, okay, so if it's kind of not neutral, okay, not neutral, okay, or some kind of a positive charge or negative charge, and then the bond number may change, okay. So for example, if it's kind of a positive charge carbon, okay, bond number become 3, okay, so can be 3 single bond or 1 double bond, 1 single bond, or maybe 1 triple bond. If the nitrogen's formal charge is 1. And then the bond could be the 4, okay, so 4 single bond or kind of 1 double bond, 1 2 single bond, and also maybe 1 triple bond, 1 single bond. And so for oxygen, okay, so if we see the positive charge, okay, will be 1 lone pair electrons and then 3 bonds, okay, and then similar for hydrogen, okay, 2 lone pair electrons, okay, and then 2 bonds for the positive charge species. And for the negative charge species, okay, so also have different bonding numbers, okay, and also the lone pair electrons, okay. For the negative charge carbon, okay, will be 1 lone pair electrons, 3 bonds, similar thing showed also here, okay. And for nitrogen will be 2 lone pair electrons and then 2 bonds, and oxygen will be 3 lone pair electrons, 1 bond, and then hydrogen there's no bonds, just kind of lone pair electrons. So those information please memorize it, okay. So that's kind of important, okay. So actually if you reach my stage, okay, so I normally don't need calculate kind of formal charge, okay, just kind of by the formula we learned in the next lecture, okay. You just look at lone pair electrons and also bonds, okay. I can predict what's the formal charge for individual atom, okay. For example, if I say oxygen has only 1 bond, okay, so 3 lone pair electrons, that should be a negative charge. Nitrogen's 4 bond should be positive charge. Okay. All right, so try to memorize this information, okay, kind of important. All right, so for the positive charge carbon, okay, so people also call the carbocation, carbocations, okay, so you'll see kind of quite often in our organic chemistry, okay. A negative charge species, okay, for the carbon, okay, so the pronunciation for this one I heard different, okay, so some professor call it carbene, okay, some professor call it kind of carbene, okay, so some professor call it kind of carbene, okay, so I heard a different the pronunciation. I don't know which one is right, okay, so maybe you guys can tell me, okay. So normally I call it kind of carbene, okay, sometimes I also call it kind of carbene, okay, so that's just same thing, okay, so and so these 2 species are very important for the organic chemistry reactions, okay, so intermediate, okay, so we will see it often in the organic chemistry. All right, and then last species is the radical, okay. Radical just the 1 single electrons, okay, on the 1 atom, okay, so can be neutral, occasionally can be even negative charge or be positive charge. So just the single electrons, okay, so. And so some reaction involve the radical as intermediate, okay. So in organic chemistry 2, we will learn very special chapter called kind of radical reactions, okay. We'll see this guy a lot, okay. Right, and then next about the bond strengths and also the bond lengths, and here are 2 okay, so 2 chart, okay, 2 tables, okay. One is about the bond dissociation energy, okay. So that's tell you what's the bond strength, okay. So so bond dissociation energy managed like this way, okay. So you have kind of 2 atoms, okay, connected by the 1 bond, okay. So this bond kind of actually 2 share electrons, and if you break this bond evenly, okay. So we call it kind of homolytic kind of the breakage, okay. And then each atom pick up 1 electrons, which is kind of radical actually. And then yeah, the energy will be caused during this process. We call the bond dissociation energy. Okay, the higher the energy, that means the stronger the bond. Okay, and this next table just kind of the bond length. Okay, all right. So if you take close look of these two tables, you'll find the shorter the bond, the stronger. Okay, for example, CH bond. It's about 1.1 Armstrong, and then CC bond is about 1.5 Armstrong, and then CH bond kind of 98 bond strongs, and then CC bond 81. Okay, so and you can find a similar trend for other bonding situations. Okay, the shorter bond, the stronger. Okay, and the two numbers you have to memorize. Okay, so one is kind of CH OH bond. Okay, those bonds are about 1 Armstrong. 1 Armstrong is the 10 to minus 10 meters, okay, 100 picometer, okay. Another number is the CC bond, okay. CC bond around 1.5 Armstrong, okay. And so those two numbers are kind of important, okay. So that's the very basic knowledge you have to learn in organic chemistry, okay. So when I was a PhD student, when I take qualify exam, okay, so there's where all the professor, okay, ask me, okay, what's the bond length of a CC single bond, okay, so I almost forgot about it, okay, yeah. All right, and the next is kind of for the same group, okay, so the bond become weaker and longer, okay, going down the group, okay. For example, the group 7, okay, CF, CCl, and CBr, and CI, okay, so and then with increase bond length, okay, from the top to down, okay, and then decrease the bond strength, okay, that's easy to understand, okay, stronger, shorter bond, okay, stronger, okay. And the next is kind of compare the tri bond, double bond, and also single bond. Okay, so tri bond is normally shorter and stronger than double bond, and then the single bond is longer and then weaker. Okay, so that's just easy to understand. Okay, so you have more bonds. Okay, the stronger. Okay, and how these two atoms together. Okay, so tightly. Okay, so that's shorter bond. Okay. And last one is CO double bond. Okay, CO double bond pretty strong. Okay, so 173, and also pretty short. Okay, so this CO double bond we call it as carbonyl functional group. Okay, we'll see it a lot in our organic chemistry, and then that's a very common functional group. Okay, to have all kinds of reaction and also different properties. Okay, so we will study later. Okay, so you can little bit just keep it in mind. All right, so again, okay, so two numbers, okay, and then others just kind of remember those trends, okay. All right, okay, so far the way we draw learn how to draw organic molecule just by just the loose structure, okay. For example, the butane, okay. So we have to show all the bond, all the atoms, okay. So CC bond and also CH bond, okay. So if the exam quiz, if you draw this structure, okay, probably take you like 30 seconds, okay. It's kind of time consuming, okay. And then the people, invent other way to draw the organic molecule, okay. The one way is to do it in a condensed structure, okay. So that's pretty much you just ignore all the kind of the CH bond, okay, and put the hydrogen, okay, so on same carbon after this the carbon, and label the repeating units, okay. So for example, the two terminal carbons has 3 hydrogen attached to it, okay, you just label as kind of C3, okay. But we still keep kind of the CC bond, okay. And the middle carbon has only 2 hydrogen attached to it, and then we label as kind of CH2. All right. And then eventually, okay, so people even ignore kind of CC bond, okay, just kind of put CH2, 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 CH3, okay, together, okay. So that's another way to draw the condensed structure, okay. Some people think kind of for the middle to CH2, just kind of repeating units, okay. So actually we can draw it like this way, okay. And then just put repeating units into the parentheses, okay, and label the repeating numbers, okay. So that's make life easier, okay. So in this case, if you draw the condensed structure for butane, okay, probably take you 10 seconds, okay, so even less, okay. Right? Is any other way we can draw the organic molecule, even easier, okay. So the answer is yes, okay. So that's kind of line angle structure, okay. So that's I call line angle structure for our textbook called kind of skeletal structure. Okay, so for the building, you just draw like this way. Right. So for line angle structure, okay, so each line represent one CC single bond. Okay, so that's one single bond to here, one single bond here, and then one single bond here. Okay, and so just keep in mind, okay, so for the end of the line, okay, so that should be kind of C3. Okay, so C3, okay, and each the vortex, okay, the angle, okay, represent one carbon atom. Okay, represent one carbon atom. Okay, so those you have to keep in mind. Okay, and so the one thing okay, that's actually carbon. Okay, so one thing is kind of when you use the line angle structures to show the organic molecule, okay, you have to really show me the angle. Okay, so for example, built-in, you need to show me there's kind of angle. Okay, so that should be kind of 120 degree. Okay, and so in the previous year, some students show me like this. Okay, it's hard to say there's some angle. Okay, so that's there's a carbon maybe here. Okay, so that's you have to show me the angle. Okay, another thing is kind of some students maybe ask kind of you show this line angle structure, the first carbon going down. Okay, can I show it up? Okay, the answer is yes. So for line angle structure, it's kind of very flexible. Okay, so you can draw the built-in like this. You can also draw built-in like this, and also even show built-in like this, and also show built-in. You can put it into vertical or maybe do another way. Okay, doesn't matter. Okay, so all are same molecule. Okay, so all contacts kind of built-in. Okay, so only the third one has a little bit higher energy. Okay, and that's we call kind of eclipse the conformation. Okay, so that's we'll learn it in chapter 6. Okay, so but all are right structure. Okay, so don't worry. Okay. Right, some other issue about use draw line angle structure. Okay, for double bond, triple bond. Okay, so double bond. Okay, so you need still draw the angle. Okay, and then still 120 degree. But for the triple bond, you need draw straight line. Right, so there's one carbon here, and then let's see two single bond. Okay, straight line. Okay, 180 degrees. Okay, the reason for that the triple bond is sp hybridized. Okay, so the bond angle should become 180. Okay, so you need to show the angle. Okay, so that's you need to show kind of straight line. Okay, so that's a little bit different from double bond and also the single bond. Okay, triple bond just show straight line. Okay, and so when you draw the line angle structure, okay, so you should able to kind of convert it back to Lewis structure. Okay, so you should have idea how many protons, okay, how many hydrogen attached to individual carbons. Okay, for example, this highlight one, okay, two carbon bond. Okay, that means this carbon should connect with the two hydrogens. Okay, that's you can convert the line angle structure to Lewis structure, convert the Lewis structure to a line angle structures. Okay. And then last issue is kind of heteroatom. Okay, so if there's nitrogen, oxygen in the molecule, okay, and if this heteroatom has the hydrogen attached, okay, so you need to keep this hydrogen. Okay, so for example, this is the 2-butanol. Okay, so the hydrogen and oxygen you still need to keep it. Okay, but the lone pair electrons you can ignore it. Okay, so the oxygen has the 2 lone pair electrons, just don't need to draw it. Okay, so those you need to keep in mind. Okay. All right, so a lot of words. Okay, so in the end, okay, so give you guys some kind of example. Okay. All right, so for example, I have this Lewis structure. Okay. Looks like a big molecule. Okay, and if I write it down, okay, take me maybe 20-30 seconds. Okay. But if we draw it's condensed structure, okay, so that's maybe just maybe 10 seconds. Okay. Sorry. Yeah, CH2, CH3. Okay. Sometimes yeah, people can also draw this kind of condensed structure. Okay, so yeah, ignore all the CC bond. Okay, but yeah, normally people don't ignore the CC double bond. You can ignore CC the single bond. Yeah, repeating unit we can put into the parenthesis. That's fine. Okay, right. So that's another way to draw condensed structure. But the easiest way, like I said, kind of use long angle structure. Like 2 seconds, I can finish draw the structure. Okay. So in the quiz and exam, okay, so you are encouraged to draw the line angle structure. Okay, so that's make your life much easier. Okay. All right. So some questions. Okay, so if I ask kind of draw Lewis structure, you draw Lewis structure, okay. But if I didn't ask, okay, so you can draw either Lewis structure or kind of line angle structure, okay. Yeah. What kind of questions, okay? So probably I will post some kind of practice exam, okay. So a practice quiz, okay. You see what kind of question you see in the practice, in the real quiz, okay. All right, last thing you guys can take a try, okay. So yeah. Try to draw the line angle structure for this 4 questions. Okay, so yeah. Oh yeah, let's have to go to the lab. Okay. Yeah, that's almost the 150. Okay. All right. So in this case, the pretty much we done the class today. Okay. So yeah, on Friday, okay, so we'll first practice draw some line angle structure, okay, for this the 4 molecule, okay, and then we continue this chapter, okay. All right, do you guys have any questions? Okay. Yeah, thank you. Yeah, thank you. All right, you're welcome. Yeah, thank you. Yeah, again, okay, please hand you exam, hand you kind of pre-lab and also the homework, okay. All right, any other questions, okay, you guys? All right. So if there are no further questions, okay, so I will stop the class today, okay. So I have office hour from 3 until 5, okay. So yeah, if you guys have questions, okay, and especially some kind of homework question or kind of pre-lab question, you can come back here at my office hour, okay. All right, thank you. Have a good day, guys.